So this is 9.5 part 2. We're going to talk about coordinate conversion. So conversion, we're going to be converting polar coordinates to rectangular coordinates and rectangular to polar. So on our kind of polar coordinate plane that we were working with yesterday, this guy, if I had a point somewhere out here, I'm going to be able to convert that polar point to a coordinate point, like a rectangular point, x, y. So we have formulas to convert from polar to rectangular and rectangular to polar. So down at the bottom, these are our coordinate conversion formulas. So when we're going from polar to rectangular, to figure out what x and y are, we just plug in r and theta. So x is equal to r times cosine theta, and y is equal to r times sine theta. Remember back before when we were using the unit circle to find cosine, sine, and all that stuff, cosine relates to x, just like sine relates to y. So that's one way to remember it. We're also still using the unit circle to figure out what cosine of theta is and what sine of theta is. And then when we're going from rectangular to polar, we have different formulas. So tangent of theta is equal to y over x, and r squared is equal to x squared plus y squared. So that's how we find theta and we find r. So in these, we're going from polar to rectangular. So our formulas are x is equal to r times cosine theta, and y is equal to r times sine of theta. So let's find our x coordinate first. We have x is equal to, what's our r? 2 times cosine of pi. This is our r, this is our theta. So what do you think I need to do next? How do I know what cosine of pi is? Let's go to our unit circle. We find pi. Cosine tells us that we have to look at what, x or y? X. So cosine of pi would be -1. So x is equal to -2. Now let's find our y coordinate. So y is equal to r times sine of theta. So y is equal to 2 times sine of pi. So go to our unit circle, we find pi. We're using our same point. What is sine of pi? The y coordinate, which is 0. So this would be 2 times 0, which is 0. So how would I write my coordinate point here? -2, 0. All right, let's do B. So again, we're converting from polar to rectangular. So we can say this is our r and this one's our theta. So x is equal to what? Awesome. Square root 3 times cosine of pi over 6. So I want to figure out what the cosine of pi over 6 is. So I'm going to go to my unit circle, find pi over 6. Cosine tells us we have to look at which one? The x. So this would be x is equal to square root 3 times square root 3 over 2. How do I multiply these together? Multiply straight across. What's square root 3 times square root 3? 3. So we get 3 over 2. Let's find y. Do the same thing. Y is equal to square root 3 times sine of pi over 6. What would sine of pi over 6 be? 1 over 2. So square root 3 times 1 over 2, 1/2. What do we get? Square root 3 over 2. How do I write my coordinate points? 3 over 2, comma, square root 3 over 2. So they end up being like the same point on our coordinate plane. So if this was a polar plane where I had like the pole in the middle, these were all of my radians or degrees around it. I'm going to plot 2 pi. So I'm going to draw the rings here so we can see a little bit better. So I go to pi, which is right here, and I would go out 2 rings. 1, 2. That would be my point. Now if I convert this to a rectangular point, on our rectangular graph, what would that point be? Negative 2, 0. We go to the left 2 and stay at 0. So they end up being the same thing. All right, let's do it again. So x is equal to what? 4 times the cosine of pi over 2. What is the cosine of pi over 2? It is what? 0. You look at the x, which is 0. So this would be 4 times 0, which is 0. Let's do the same thing for y. Y is equal to 4 times sine of pi over 2. What is sine of pi over 2? 1. So y is equal to 4 times 1, which is 4. So our point would be 0, 4. So x is equal to 2 times cosine of pi over 6. What is cosine of pi over 6? Square root 3 over 2. So x is equal to 2 times square root 3 over 2. So x is equal to square root 3. Let's do it again. Y is equal to 2 times sine of pi over 6. What's the sine of pi over 6? 1/2. So y is equal to 2 times 1/2. So y equals 1. So our coordinate point would be square root 3, 1. Next page, we're converting from rectangular to polar. So we have 2 different formulas here. So r squared is equal to x squared plus y squared. And then tangent of theta is equal to y over x. So let's find r first. We have r squared is equal to 2 squared plus 2 squared. So r squared is equal to 4 plus 4. R squared is equal to 8. Take the square root. What is r? Awesome. Always simplify it. So that would be 2 square root 2. Now let's find theta. So tangent of theta is equal to 2 over 2. So tangent of theta is equal to 1. Now we want to figure out where tangent is 1. Tangent, we know, is y over x. Which degree measure, which radian measure would give us 1 here? Awesome, pi over 4. So theta would be pi over 4. So when we put this as a point, we would get 2 square root 2, pi over 4. Your formulas for this are always this to find r, this to find theta, when you're converting from rectangular to polar. Now, yesterday we talked a lot about how we can have the same point. So if 2, 2, if we had a plane here, 2, 2 is to the right 2, up 2, over here somewhere, let's say. We could have this point, but it could have different polar coordinates. Remember that we said we could go this way, but make it negative and do that. I just want the positive version, so don't convert this to negative, add pi here. Just give me the positive one. If we did, tangent would also be 1 here at 5 pi over 4. Just stick with the first quadrant or the second if you need to. Okay. Don't get tricky with it. Ms. Boyd talks about it in her video. She says, I will mark it wrong if you make me look for it. But just stick with the first quadrant. Don't do extra work that you don't need to. Any questions there? All right, let's look at the second one. So let's find r first. So we know r squared is equal to -1 squared plus 0 squared. So r squared is equal to 1 plus 0. R squared is 1, so what is just r? 1. Next, let's find our theta. So tangent of theta is equal to y over x, so 0 over -1. So tangent of theta is equal to 0. So we got to look on our unit circle and see where y over x is 0. For this example, it actually might even be easier just to leave it as 0 over -1 because that tells us that it is 0 and -1 that we're looking for, not just 0. Oops, that would be this one here, where y over x would be 0 over -1. So what would theta be? Pi. So I would say don't even simplify your tangent. You can just leave it like this to tell you that you're looking at this point. If we did y over x for here, it would be -1 over 0. Not the same. So this would be pi. All right, C. We're going to do the same thing. R squared is equal to x squared plus y squared. So r squared is equal to -1 squared plus 1 squared. R squared is equal to 2. Take the square root, so r is equal to square root 2. So let's find theta. Tangent of theta is equal to y over x. So that would be 1 over -1, which is just -1. We want to go to our graph and figure out where -1, 1 is in our rectangular plane because that'll tell us which coordinate we got to look at. So if I go to the left one and up one, we're going to be over here somewhere. So I want to look at the second quadrant here. So in the second quadrant, if I did y over x to find tangent, to find theta, what would give me -1? 3 pi over 4. Perfect. This one. So this would be theta is equal to 3 pi over 4. Now, also, if we picked 1 over here, this would also, 7 pi over 4 would also give us -1, but we know that our point has to be up here somewhere, so that's why we picked this one that gives us -1. If we would have done negative square root 2, we could pick this one because negative square root 2 would bring us back over here. But just stick with the positive one. Don't get tricky with it. Just if it helps plot your point first, figure out where your point is. So that tells you what direction you got to look for when you're looking to see when tangent is -1. So our point here would be square root 2, 3 pi over 4. So for D, let's plot our point first to figure out about where we're at, what quadrant we need to look at. So we're going to go to the left, -1, and up, square root 3. So we're going to be over here in this quadrant. I don't know where exactly, but in this quadrant. So now let's find our r and our theta.